Multiplication of vectors. Here is an application. We are trying to find a unit vector. So the question is, determine unit vector in the direction of the given vector. So we are given a vector here, vector A, with tail at -1 plus 1. So the tail here is at -1, 1, and the head is at 2, 5. Right? There is our vector A. We can also write this vector A as A is equals to in Cartesian format. So the x value, if I translate this vector, let's say to the origin, right, then it becomes a position vector, and then where will this coordinate be? So we can find it like this. X displacement is, if you see the vector, 1, 2, 3. So we get 3 for x displacement, and y is 1, 2, 3, 4. So this is same as 3, 4, right? So that is how we can actually see this vector as. So you can call this vector A as a vector with tail at -1, 1 and head at 2, 5. That's one way to represent this vector. The other way is vector with square brackets 3, 4. So when you put these Cartesian coordinates in square brackets, they represent vectors, correct? So it is a vector A. Now, what is the magnitude of this vector? Say magnitude of vector A is equals to square root of 3 square plus 4 square, correct? Which is square root of 9 plus 16. And that is 25, and square root of 25 is 5. So that is the magnitude of this vector. Now if I divide vector itself, which has both magnitude and direction, by its magnitude, then its magnitude will become 1. That means 1 unit. And direction will remain same, correct? That is what a unit vector is. So we sometimes represent unit vector as this, right? This particular symbol represents unit vector, right? I've not seen this in many books, but that is sometimes. Otherwise, you just write unit vector. So we say this unit vector is actually equal to the vector itself, which is 3, 4, divided by its magnitude, which is 5. Correct? So what we have done here is, basically, we are writing unit vector as vector A divided by its magnitude A, right? So once we divide the magnitude by its magnitude, then the magnitude becomes 1 unit. So we get a unit vector. But the direction remains same, correct? And therefore, this represents a unit vector. So you could either write this as 1/5 of 3, 4. So that means 1/5 of this will be a unit vector in the same direction. Do you get it? So it also gives you the direction. So 1/5 of this, correct, gives you the direction, right? It is normally better to show it with tail at the origin, right? So if I draw a vector parallel to this, let's say kind of like this, and 1/5 is probably, let's say this much, right? So we said this is a unit vector which represents actually a vector with magnitude 1, a unit vector for vector A. It's in the same direction, and the length of this vector is 1/5 of this, right? 5 is the length for this vector, 1/5 is this. So 5 divided by 5 is 1. So this magnitude is 1 for us, and that is my unit vector for the given vector, right? So that is how you can find unit vector for any given vector, correct? I hope you understand and appreciate it. Thanks and all the best.